Hi, welcome back. Now we will start by studying problem 59. Please let me know if you have any questions. So the first thing here is to actually understand that what you need to do here is related to something called the law of sines. But why do we have to use this formula? Could there be a way that without having to resort to something that we have learned by heart, would it be possible for us in this moment to solve it anyways? So what I will do right now is actually the derivation of the law of sines. So in case you don't remember exactly what the law of sines looks like, you can actually derive it. It's a pretty easy exercise. And for that, let's do the following. So basically, what we have here is that for any triangle, let's call this the angle A, the angle B. Wait, so we can relate it to this exercise later. Let's call it in this way, just like what we see there. And let's call this angle, this side, we will call it with the same letter as the opposite angle. This one we can call it XV, and this one we can call it XC. So how can we derive this formula? It's a pretty easy exercise because what we can do is, let's erase this, is actually tracing a line here such that these and these are 90 degrees. So we have been able to form two triangles, rectangular triangles. And in what way is this helpful? So the thing is that, let's call this y. What we have now is that these two, this triangle and the other one, that are now sharing in a way y, we can relate them. And it is this relation that actually brings the law of sines. So how can we relate an angle to the opposite side? So we know this is the sine function will actually provide to us sine of A is equal to y divided by the hypotenuse of this triangle. And we can do the same actually for sine of B equals to y divided by xa. So if we match these two equations, we can see that, okay, let's do the intermediate step for those needing that intermediate step. From the first equation, we can write this, and from the second equation, we can write this. So now, if we omit writing y in one of these sides, and we just write this one or this one here, we see that we can actually write this equation. So it is actually from here that if we divide xa over sine of A and xb over sine of B, that we have derived the law of sines. And because this trick can be done for any triangle and for any of the different sides. So let's see, here we could also have drawn this line that more or less is perpendicular to this one, and we can do the same one here. So it is exactly because of this property that you can always create two rectangle triangles, that you can always relate two sides with the corresponding angles in this way. So now that we know this, let's solve the problem. Wait me for a moment. Okay, so let's see. We want to find the size of this string. We know this angle, that is the opposite angle to this side. And we know the only side that we know the size of it is this one. And this angle can be computed very easily by just adding 75 to 45 and subtracting 180. And we see that this is 60 because this here is 120. Okay, so if we now use this formula, that means that if we take 240 feet and we divide it by sine of 60 degrees, that should be equal to the string, the length that we want, divided by sine of 45 degrees, which is the opposite here, and this is the opposite here. So from here, we can just write string equals to sine of 45 degrees divided by sine of 60 degrees, and this times 240. So, okay, so sine of 45 degrees, this here, is 1 divided by square root of 2. And this one here is a square root of 3 divided by 2. So we see that if we substitute these values, what we get here is actually 2 divided by square root of 6 times 240. And the next step here is realizing how 240, okay, so if we were to use the calculator here, we would get something around 196, but none of these answers is related to 196. So a good way of doing this is already being pointed out by the square root of 6. In a way, it looks like this could be the answer, but let's corroborate this fact. So 2 and 240 can be written by 3 times 80. So we have this. This is the square root of 6, and this here, my friends, is 6. So basically, because 6 over square root of 6 is equal to square root of 6, we get this. And we have shown that this is the answer. So here we not only found the answer, but we also explore how we can derive, without resorting to memory, we can always derive the law of sines by realizing this trick that you can always make any triangle. You can always create these lines that are perpendicular to one of the sides. And it is through that kind of argument that we are able to compare angles and sides, angles and the opposite sides, and find the ratios that defines the law of sines. So hopefully this help you. If you have any questions or if you would like me to explore more of these exercises, just please let me know down below, and I will very